Welcome to this DaVinci Resolve Fusion node breakdown. Today's node is the Custom Vertex node. So we're going to jump into Fusion, and to be able to go over the Custom Vertex node, we're going to need some 3D shapes here. So let's go ahead and grab a cube and make it a cube. And let's add a 3D merge node. So what the Custom Vertex node does is it kind of acts like the Custom Tools node we went over yesterday. So Shift Space, Custom Tool node. And if you remember right, we had controls for all of our points and our numbers. And the way this one operated is we did our expressions on the channels level to bring in those images and the channels level. Then we could do a setup for our frame related stuff and integer expressions for our pixel level stuff. And of course we can configure and change our points, numbers, and LUTs. And the custom vertex node is similar to this, but it operates on the 3D vertex level. So let's go ahead and bring in a custom vertex 3D node and let's take a look. So if we look up top, it looks pretty familiar to our custom tool node. The only difference is on our custom tool node, if you remember, like I said, we brought in our channels to do all the compositing, did our expressions in here. On the custom vertex node, we do it on the vertex tab. So whether it's to do with our position, our normal, our vertex color, texture coordinate, environment coordinates, our tangent u, tangent v, or our velocity, we do all of our expressions right in here. And the way our expressions work is by default, it's showing you what our expressions are. So the px is the expression for our position x value. For our normals, it's nx for our normal x position. And then our velocity is Vx. So if you just look at all this stuff, these are the expressions for these specific things you can change and add expressions to. So going back to position, and I'm not even going to lie, I have honestly never used this in production for anything within Fusion. And primarily because I use Houdini for all my 3D stuff, especially when it comes to procedural 3D stuff. And I use Blender as well. So I pretty much never use Fusion to actually create 3D things. I'll import them, but I'll create them in Houdini or Blender. So I'm going to cover what I think I know about this node. I've used it years and years ago, but I will do my best to do a correct breakdown. So on our configure button, we can do the same thing as we could with our custom tool. We can go and change how many controls we want. So for our numbers, if I want to only have 7, if I go to our numbers, there's only 7. Or I can have all 8, there's all 8. And same with our points, our image controls, which we will go over. And for our LUTs. Now our LUTs within the Vertex node operate differently than they do in the Custom Tools node. Basically, if we use these LUTs like our get LUT that we kind of went over yesterday, instead of actually getting colors, it's going to apply these curves to our actual vertex positions and different things we change. And then of course we have our setup, which if you remember right, is our frame based stuff. So this operates on the per frame level. So any expression you put in here will operate on the per frame. So we could say in setup 1, time divided by our timeline, which is 190, which means every frame is going to do whatever we tell S1 because our expressions for our setups are S1, S2, S3, and so on. And then we have our intermediate, and this is where we can add additional expressions. And our expressions for our intermediates are I1, I2, and I3, and so on. So let's jump into this so you can kind of see what is happening with this node, because it is kind of confusing and it's extremely in-depth and extremely complex, but I'm not a mathematician, so I'm going to keep it fairly simple. So what we could do, say on our Y position, if we wanted our little shape here just to be on the ground level and never go beyond ground level, we could just go in our Y position and we could type max, open bracket, 0, comma, py. Now our little shape is going to stay on the ground there, but notice it shrunk because basically what it's doing is it's changing or cutting off our shape on that ground level. So if we go to our shape and I go to our Y, you can see I can change our little Y, and let me change that location so you can see it better. It's staying on the ground. But what I could also do is I could right click and I can select publish. So we're publishing that Y scale. I can go to my custom vertex node here, and I can go to my numbers. I can go down to this number 8 or whatever number I want, connect to shape Y scale. And then I'll go over here and I'll change our little number controls to say Y scale. So now if I go to numbers, you can see it says Y scale. And just as a reminder, yesterday I forgot to mention, no matter what we change these names to, our expressions for these stay the same. So even though I changed that to Y scale, our expressions for this is still N8. So if I jump back into our little Y scale, now on our custom vertex node, I can change the scale. Then if we move over to our points, we can select points on here. So I can click, hold, drag, and select a point. And let's go ahead and get a point right on that. So I'm going to switch my camera to front, zoom in super close, and make sure we're right there. And that's good. I mean, I can move it up top if I wanted to, but I just want it on that side. So now my little point that I selected is on the side of our shape. And then what I could do is to be able to use this point to squish our shape down. I could go to our position vertex here and under our X, because we're working on the X. I could type, let's see, it would be min, and I want 0.1x, comma, px. Because this is how our points are named. So if I go to our points, 0.1 is going to be 0.1x or 0.1y or 0.1z. 0.2 would be 0.2x, 0.2y, 0.2z. So that's how we would write those expressions. So now if I go to my little point here and I move my X, you can see we are squishing our little cube there. So if I wanted to add another cube to be able to squish this down, I could. So we can add another shape. And let's make this a cube. And let's look at our cube here. I'm going to go to our transform and just make this 0.25, 0.25. And we could actually do the same little trick with our bottom there if we wanted to. We could add a custom vertex node and go to our little Y position and type max 0, comma, py. So now it's always going to be on ground level. I can go back to my shape and let's make our little shape taller there. So now I want to connect my little location of this cube to my custom vertex. So what I could do is I could go to my custom vertex, right click, I can publish my X location there. If I go back to my shape, right click, connect to custom vertex, my X, and let's go ahead and merge these together. So now if we look, we've got the two, and if I go here, change my points, notice it's moving and squishing in, but you can tell that's off. So what we need to do is I need to change it to where it's squishing. And then go to my little shape here, and let's go to our front, and let's change the colors of our shape so we can tell what's going on here first. So nice little purple, nice little green, and I'm going to go to my transform, my pivot. I'm going to zoom in, and I'm going to change my pivot on my X here to bring it into where it's just touching that. So now if I go here and look at my perspective and I change my little X, we can see it's squishing. So, and if I really wanted to, I could go to my numbers here. I could take this one, connect to my X position, Go here, rename this to squish. So now if I go to my numbers, I know that's my little squish, and now I can squish my little shape. So you can see how this can be pretty powerful when it comes to procedural and interactive stuff, or even time-based stuff, because we could go back to our little vertex here, our position, and under our Y position, I could say times S1, because if you remember right, in our setup one, we changed that to time divided by 190. If I go to our vertex and I push play, you can see it's automatically growing based off time. And if I wanted to be faster, I could go to my setup and say time divided by 1 times 2. So it's even faster. And I can still come in here and squish down my little shape as it's growing and getting bigger. So let's go here and let's get rid of this. Now we can do other procedural type stuff. So we could probably make a little procedural roof on there if we wanted to. So let's see, how will we do that? We could, in here, let's say, I'm going to need 2 little integers. So let's go to our numbers first, and let's rename some of this. So number 1, I'm going to need this to be threshold, and this is going to be the pitch of our roof. So now we've got threshold and pitch. So number 1, number 2. I'm going to go here under our Z because we want it on our Z axis, and I could write if or PY is greater than N1, so greater than our threshold. Then we want our PZ to be multiplied by our pitch. And just in case that all gets jacked up, we want it back to our regular PZ. So there we go. So notice we've got a little pitch thing going on there. So if we go to our numbers, we can change our threshold here, bring it up to the top. And we can change the pitch of our roof. And if I change my scale, you notice it's not scaling up with that, but we can change our threshold again, bring our threshold up and rechange our pitch. So we've got a little roof there. And again, we can still squish this if we want, because we like squishing things. So the more creative you are and the more you know math and the more smarter you are, the more things you're going to be able to do with this, you know. But the one thing we didn't cover are these image inputs here. And these image inputs are a little different than our custom tool here. So let's go ahead and let's delete all this out. And let's refresh our little node here. Let's go ahead and refresh our shape too. Oops. We wanted to keep our cube. So the way that our images work is, if you remember on our custom tool, if we brought in image 1, we just went to our channels here and we had image 1, each channel reflected with R1, G1, B1, and A1. It's kind of the same thing on the custom vertex, but we're not actually bringing in images. We're bringing in information based off that channel. For example, we could, let's create an image. So I'm going to rescale this down because our square is square. So I'm just going to say it's 1200, just a random number. 1200. So we've got a square for our little UV texture there. And I'm going to bring in another square on our square. So that's the little image we're going to be using to manipulate our vertex. And what it's going to do is it's going to allow us to create geometry or alter geometry based off our image. And before I do this, I'm probably going to want a UV map because I want to make sure we're retexturing this correctly. So shift space UV map. And I'm going to want it on the X. So if I go to our custom vertex node here, first thing I need to do is be able to bring our image in. So our inputs are image 1, image 2, and image 3. And if you remember right, we can go to our configure button, go to our image controls, and I can shut off image 1 and 2. So I don't have those annoying little inputs there. But what we need to do is bring this information in. And how we do that on a custom vertex node is we'd have to use our intermediate to code it and kind of bring that information in. So what we want to do is we want to use just a get statement. Whereas on our custom tool, it just R1 said, hey, R1 do this, R2 from channel 2 do this. We have to use get information here. So we're going to say get on our red channel from image 1, so R1. And we want our W, because if you remember right, our UV textures are actually UVW textures. So U on the X, U on the X, V on the Y, and then W on the Z. So we can get that W texture to extrude out. So we want that W. And what we want is we want our tangents of the U and the V. So I'm going to type open bracket TU, comma, TV, close bracket. So now we're pulling in that information. And if I go to our images here and let's go to our X position so we can pull it out on our X. If I say if PX is greater than 0.45, that's just, we want it greater than 0.45. Then we want our PX to add I1, which was, if you remember, we wanted to add I1. So that means add our image as geometry. And if it all fails, just return it to PX. So there we go. If you notice, nothing exciting happened because we're pulling on our red channel and right now we have no colors going on and we need red. So as soon as I push red, look at that, we've got a little extrusion coming out and it looks a little large. So let's go to our rectangle here and let's split. So let's look at our background. Let's change the scale of our rectangle or our square so it's a little smaller. And if you see, it's extruding out, but it doesn't quite look right. And the reason is for us in the 3D world, we know that's all dark. That means there's something wrong with our normals. So all we have to do is go out after our custom vertex node, shift space, replace normals, and add it, and we're good to go. So now we can look at this. So we've got our little extrusion from our rectangle here. And let's bring that back up. So no matter how we change our image, you notice we've got our little extrusion. Gonna recenter that. Let's change this to 0.1 to 0.1. So we've got a small one. And if we go to our UV map here, we can kind of fix our little UV map here so we can change our scale down. So now it's scaled correctly to our little cube there. And again, we can go to our rectangle and we can change our size up if we want. Make it a little bigger. So there we go. We've got a bigger one. Now, what's going to dictate how far this sticks out is our red channel. Because if you remember right, we are bringing in our red. So if we go here and go to our background, we can change our red color down so it's bringing in less red. And you notice it's changing that scale. And then of course we can come to our UV map and we can change a bunch of stuff on our UV map if we want. We can make it rotate around, and we can even tile it if we want. So we could say 3 tab, 3 tab, and we've got a bunch of them. And then of course, if we go to our little custom vertex node and we go to our statement for our vertex, you notice we are adding. So technically we can subtract if we want. So I can say minus. So now we've got holes in our little cube instead of it extruding. And again, if we go to our background, our red color is going to dictate how far those extrude in to our little shape. So that is the custom vertex node, and really the only way you're really going to learn this node is to start playing with it and start doing different things, inputting different expressions, and you'll come up with something. So I will see you in the next node breakdown.